All right, right now we are talking about Chapter 2, Section 1. We're going to be talking about linear equations and two variables. All right, so let's see. All right, so let's read this from the top. One application of algebra is the graphical representation of numerical information or data. For example, Table 2.1 shows the percentage of individuals who participate in leisure sports activities according to the age of the individual. Right? It's just a table. Nothing too much, right? It's just information or data, right? All right. Coming down here, information in the table Information in table form is difficult to picture and interpret. However, when the data is presented in a graph, there appears to be a downward trend in the participation in leisure sports activities as age increases, right? So, like I said, it doesn't necessarily show it. Okay. I guess it doesn't really show it. Where is it at? Figure 2. It says figure 2.1. All right, well, it doesn't show it. But if we were to imagine, let's not do that. Let's not do any imagination here, because many of you, might not have taken math for a long time, so we're not going to just imagine things right now. So, anyways, let's just proceed here, right? To picture two variables simultaneously, we use a graph with two number lines drawn at right angles, and okay, we have animations here. So let's see here. How can we? No, I don't want to. Well, let's see.
When two variables are...
No, I don't want to do that. I don't want to do that. I would rather just instruct. All right, so let's, for right now, actually skip this part. We're not skipping too much. Matter of fact, here's what we can do instead. Let's just go here, right? So we're going to talk about graphing points, right? Points graphed in a rectangular coordinate system are defined by two numbers as an ordered pair, x and y. The first number, called the x-coordinate, is the horizontal position of from the origin. The second number, the y-coordinate, is the vertical position from the origin. All right, example 1 shows how points are plotted in a rectangular coordinate system. So let's check that out. Let's see. I'm really curious why my figures are not showing up. Figure 2.3. Okay. It's interesting. It shows up on my desktop. It's just not showing up on my laptop for some reason. Anyways, let's do this. Okay. So we're going to plot these points here. All right. So it says plot each point and state the quadrant or axis where it is located. Okay. And it didn't really tell us information about quadrants. So what I'm going to have to do is go over that, or I guess that's what this is talking about here. Okay, that's interesting. Alrighty, so before we actually begin this, let's talk about the rectangular coordinate system. Okay, so the rectangular coordinate system is this little thing that you right, the graph. Okay, well, up here in this upper right region, okay, that is going to be called quadrant 1. Right. This particular quadrant, what we do is we go counterclockwise, right? So this particular quadrant here is quadrant 2, and then as you'd imagine, quadrant 3, and then quadrant 4. Okay. Why'd I use Roman numerals? I don't know. I could have just wrote numbers, right? But that's how the quadrants are labeled on a rectangular coordinate system. Right. Now let's erase those and look at these points here, okay? So this reads, plot each point and state the quadrant or axis where it is located. All right, so in the textbook, right here, it says that the first number, called the x-coordinate, is a horizontal position from the origin. Okay, well, what is the origin? Well, the origin is this point right here, the very middle. Okay, that origin has a point of 0, 0. Okay, and so when we say the first number here is the horizontal position away from the origin, that means how far to the left or right are we moving, okay? If we move to the right, it's going to be a positive number. If we move to the left, it's going to be a negative number, okay? Similarly, if we talk about the y-axis here, okay? Again, going back to the textbook, it reads that the y-coordinate, so the second number called the y-coordinate is the vertical position from the origin, okay? So the vertical position from the origin, right, if we go up, we're going to be positive. If we go down, it's going to be negative. All right, so what does all that mean? Well, let's plot some points and get a better idea, okay? So it looks like I need to, go to at least 4, okay? So we'll go 1, trace again, we'll go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so starting with A, right, we're going to plot the point 4, 1. Right, so what that means is we're going to go, it's a positive 4, okay, that's on the horizontal portion of the rectangular coordinate system. It's a positive 4, so we're going to go right 4 units, right? So we're going to go to right here, 4. Okay, actually, no, I shouldn't have done that. I shouldn't have marked it in, sorry. We'll just keep the arrow there. We're going to go over to the right 4 units. And then we have a positive 1 here, so this means we're going to go up 1 unit. Okay, so see, this is 1 unit here. Let's see, this is, well, I don't know if you can see those dotted lines. I can barely see them. But we're going to be going up 1 unit, so we'll just keep it a vertical line there. Okay, so right there at the tip of that arrow, I will make a point. Okay, so right here is the point 4, 1. Right, and forgive me, for this particular blackboard, I guess it's touch screen, my dots look a little. Now, I guess I can make them a thicker line and just kind of peg it. Maybe that. Let's see, can I get a big peg? No. Okay. So the pen doesn't peg as large. So I have to kind of start a dot and then kind of roll around. Okay. So that's how we proceed. All right. Well, that's A. Right. B is a negative 3/4. So similar process. I'm going to go okay. The negative 3 means I'm going to go on the left on the horizontal axis. 1, 2, 3 points. And then I'm going to be going up 4 units, right? Because it's a positive 4, so we're going to be going up 4 units to right here. Boom. Right, there we are at negative 3, positive 4. So let's put it right here. C, we have 4, negative 3. So that means we're going to be going to the right 4 units and then down 3 units. So we're going to be going right 4 units and then down 3 units. So our point's going to be right here. Okay, so let's erase those. 4, 3. Right, and then let's right now skip D. No, let's not skip D. There's no point in skipping D, I guess. I just want to hit E and F real fast. But we'll just go ahead and do D. So it's negative 5 halves. Okay, so negative 5 halves. That's the same thing saying negative 2 1/2, right? So negative 2 1/2. We're gonna have to start back over with red. Negative 2 1/2. Well, I guess we're gonna do yellow. Huh? So negative 2 1/2. Well, if I'm going here, that's 1, negative 2, and then negative 2 1/2. That's about it right there, right? And this will be a negative 2, so that means we're going to be going down 2 units to right here. So my point is going to be something like this. So negative 2 1/2, negative 2. Okay. Now let's look at E and F. E and F are kind of a big deal because E is the point 0, 3 and F is the point negative 4, 0. Okay, so it might seem a little what am I trying to say? A little weird, but it behaves exactly like you think it would, right? If 0 is the x-axis for E, or the x-coordinate rather for E, then that means we're basically not going anywhere, right? So that means I'm not going left or right, so we can just kind of, in a way, forget it. And then the positive 3 in the y-axis means we're going to be going up 3 units, and that's going to be our point right there. Okay, and then f is very similar. We're going to be going left 4 units, right? Because it's the horizontal number. We're going to be going left 4 units, and then the y coordinate is 0, so it means we're not going up or down. So we're just going to stay the same. So we would just simply go left 4 units. Okay, so that's E and F. Let's go ahead and just denote that as E and F, just for fun. Okay, all right. So that's example 1. Okay, we're going the wrong way here. There we go. All right, so now we get some definitions, and let's actually go ahead and snip the problem with it. How about that? Or the example with it. All right, so let's start from the top here. It reads linear equations in 2 variables. Recall that an equation in the form ax plus b is equal to c is called a linear equation in 1 variable. In this section, we will study linear equations in 2 variables. All right, so we've got. Can y'all see that thing that says assignment there? There we go. We got it off. Okay. All right, so in this section, we will study linear equations in 2 variables. So the definition reads, let a, b, and c be real numbers such that a and b are not both 0. A linear equation in 2 variables is an equation that can be written in the form ax plus by is equal to c. This form is called standard form. So a solution to a linear equation in 2 variables is an ordered pair xy that makes the equation a true statement. So what we must do in this particular example is we need to determine whether the ordered pair is a solution to the equation negative 2x plus 3y is equal to 8. So in order to determine that, what we're going to have to do is we're going to have to plug in these values into this equation for their x and y respectively. Okay, so let's go ahead and write this equation out. We're going to do negative 2, and then let's make the x be red, 2x plus 3y. We'll make the y be blue, and that's going to be equal to 8. Okay. All right. So I denoted them red and blue because what I'm going to do is I'm going to say the x values are going to be red, and then the blue values are going to be y. Wait. The blue values. X is red. Blue is. Wait. No. X is red. Y is blue. That's what I'm going to say. X is red. Y is blue. Okay. So by writing this particular problem out, right, we'll start with a. What we're going to do is we're going to say negative 2, and then it's going to be times what? Negative 4. Okay, because that's the x value, and then plus 3, and then the y value is going to be 0. That's going to be equal to 8. Okay, so finishing or doing the arithmetic here, we have negative 2 times negative 4. That's going to be a positive 8 plus 3 times 0, which is 0. That's going to be equal to 8. Okay, so it looks like A works. So we'll put a check mark next to A. Let's see. Try that again. Put check mark next to A. A does work here. Okay. So that ordered pair is a solution to that equation. All right, let's try another equation or another ordered pair. So the next step we have 2, and then we have a negative 4. That's a horrible looking 4, isn't it? Okay. All right, so I've got 2 times negative 2, that's going to be a negative 4, and looks like minus 12. Okay, well, negative 4 minus 12, that's going to be equal to negative 16, which is not equal to 8. Okay, so therefore, this ordered pair is not a solution to the equation, right? So we'll put an x here. That is not a solution. All right, and last up we've got a 1 and 10/3. So a 1 for x, and then a 10/3. Let's fix that. Oh yeah, small 3's end up looking a little weird for me. But anyways, on this, with this blackboard we're using. But anyways, so negative 2 times 1 is going to be negative 2. And then a plus 3 times 10/3. Okay, what's 3 times 10/3? Well, the 3's cancel, so we're going to have a plus 10. Okay, well, negative 2 plus 10 is indeed 8. Right? So this is true. So 2 of these 3 numbers are a solution to this particular equation. Right? And that's how you do that. We will, let's just snip this for right now. I don't know, maybe I can snip the equation too. We'll see. So new page. Okay, so I'm going to work this out the best I can, and then I'll give you the nice, pretty graph, right? Because I mean, just like you guys, I'm not that great at freehanding a nice, pretty graph. Okay, but let's read this from the top. It reads, by graphing these ordered pairs, we see that the solution points line up. See figure 2.4 is not here. You have the textbook though. There are actually an infinite number of solutions to the equation x minus y is equal to 3. The graph of all solutions to a linear equation form a line in the xy plane. Conversely, each ordered pair of the line is a solution to the equation. So this definition reads, the graph of an equation in 2 variables. To graph an equation in 2 variables means that we will graph all ordered pair solutions to the equation. To graph a linear equation, it is sufficient to find 2 solution points and draw the line through them. We will find 3 solution points and use the third point as a checkpoint, right? So it says this is demonstrated in example 3, so let's go ahead and get started for example 3. We need to create a graph here, or I'm sorry, a rectangular plane. Not sure how far I need to go out. Looks like 5, okay? So we'll do 1, 2, 3, 4, 5. Okay. All right, so in order to graph this particular equation, what we need to do is figure out well, there's a couple ways to go about it. How does the book want us to do this? Well, we can't do 0 intercepts. All right, so real quick, let me see exactly what the book is trying to figure out for us to do. Okay, so it's giving us a table, it looks like. All right. It's giving us a head start on a table. It's not my favorite way to go about this, but we'll deal with it. Okay, so what we need to do here is we need to figure out what the other ordered pair is. So we have a point here, a point here, and a point here. Okay, we need to figure out what those other numbers are. So in order to do that, what we need to do is substitute these numbers into the equation. So for instance, this first one is a 0, so we plug a 0 in for x. Well, that just becomes 3 times 0, which is 0, so 0 plus 5y is equal to 15, and then if we divide both sides by 5, we have y is equal to 3. Okay, so I told you 3 is kind of messed up there, right? Can't draw 3 for here. All right, so we can say that this point right here is a 3. It's not the let's try this. Let's make it larger. Let's try that out. Maybe that'll help. Okay, so we need to put a 3 right there. That's not bad. All right, so next up, we need to figure out what this is. Okay, so what we're doing here is now we're going to be plugging a 2 into the equation. Okay, so let's do a different color here. Let's do blue. All right, so we've got 3x rather, plus 5 times 2. That's going to be equal to 15. Okay, well, so we'll have 3x plus 10 is equal to 15. We're going to subtract we're going to subtract 10 from both sides, so we're going to end up with a 3x is equal to 5, right? And then we divide both sides by 3, so we have x is equal to 5/3, right? So luckily we have a nice, pretty fraction. So I'm not going to be able to fit a fraction in there, so we're just going to put a little arrow here saying 5/3. Okay, and again, all I'm doing is I'm just simply plugging in the values that I see there. All right. Yeah, I guess that's what they want. That's unfortunate. It's an interesting thought that I've been doing this a long time, and I still hate fractions as much as you probably hate fractions. Right. Anyways, last thing, we're going to plug this 5 in to that equation. So we're going to have a 3 times 5, which, 5 is the x, plus 5y. That's going to be equal to 15. Right. So we've got 15 plus 5y is equal to 15. That's pretty easy, right? So I'm going to subtract 15 from both sides. So I'm going to have 5y is equal to 0, or in other words, y is equal to 0. Okay. So this is 0. And we'll erase this. And like I said, what I'm going to do here is I'm going to, let's see, well, no, we won't do that just yet. All right, so let's go ahead and plot these points. All right, so we have the point 0, 3. So we're going to go, we're not going anywhere on the x-axis, and we're going to go up 3 units on the y-axis. So 0, 3 is located right here. Next up, we're going to have a 5/3 and a 2. So we're going to go, looks like we're going to the right, like 1 2/3. Okay, so that's very unfortunate. I hope we're correct here. But we're going right 1 2/3. So 1 2/3. So it's about right here. It's about 1 2/3. Then we're going to be going up 2 units. So we're going to go up to right here. Yeah, everything lines up. Looks like. All right, there's the second point, and then the last point is 5, 0. And let's actually fix that because it just looks like I'm circling it. I don't know. How can I put a 0 there? That looks like a 6. That'll do. All right. So 5, 0 means I'm going to be going right 5 units. And, oh gosh, this looks horrible. And I'm going up or down no units, right? So my point's going to be over here. And as you can tell, you can kind of, if you fudge it, I guess, you can kind of say it's a straight line. Excuse me. But instead, let's show you what the nice, pretty graph looks like. Right. We did it correctly. It was just there were some parts of I'm assuming my rectangular coordinate system that doesn't seem like it's straight-ish. I don't know. But we did do it correctly, and that is how you graph a linear equation in 2 variables. This is such an extremely long section that it's so hard. There we go. Was that example 3? Okay, example 4. We're going to be graphing a linear equation in 2 variables. Okay, so same thing. And honestly, what we're going to do is kind of hand wave through this because, well, that's horrible. It's the same procedure we just did. Except we have more fractions. Okay, so I think we're going to hand wave through this a little bit, right? So this reads, graph the equation y is equal to 1/2 x minus 2, right? So solution, because the y variable is isolated in the equation, it is easy to substitute a value for x and simplify the right-hand side to find y. Since any number can be used for x, choose a number that are multiples of 2 and that will simplify easily when multiplied by 1/2. So The idea here is that we have a table of x's here, okay, and we are going to choose these x's specifically because 1/2 times these numbers give me a whole number. So, I mean, 0 is obviously an easy one, right? 1/2 times 0 is simply 0. However, 2 times 1/2, right? So 2 times, well, let's do it the other way. Let's say 1/2 times 2, right? This is just simply this portion right here. Okay, we know that 2's cancel, we'll just have 1. And similarly, if we have a 1/2 times 4, we know that this becomes a 1, this becomes a 2, right? And we just simply have a 2. Okay. So that's why we use, I'm sorry, not 2. Yeah, it is 2 actually. Sorry, it is 2. I got ahead of myself. It is 2, right? And then we just solve the equation from there. Or we solve for y, rather. We solve for y. We don't solve the equation, we solve for y. So, let's go down here. Down here, we've got y is equal to 1/2 times 0. Okay, well, again, anything times 0 is simply 0. And then 0 minus 2 is a negative 2. So we'd put a negative 2 right there. Oh, well, I guess it is handled over here, huh? There we go. And then again, just plugging those numbers in, we end up getting these values of y out. So by getting those values of y out, we now have coordinates, and then we plot those coordinates. Okay. So again, absolutely nothing different than what we just got done doing. It's just now that I guess we have a fraction there. All right. So next up, we have the x and y intercepts. Ooh. Here we go. All right, so this reads, for many applications of graphing, it is advantageous to know the points where a graph intersects the x or y axis. These points are called the x and y intercepts. All right, so let's snip this definition page. And we'll go ahead and put the determining the x and y intercepts here as well. Alrighty, so the definition of the x and y intercepts. An x-intercept is a point A0 where a graph intersects the x-axis, okay? So what this means, A0. Notice how A is the variable. A is the one that can change, okay? 0 is the number that stays the same. And it makes sense, right? Because if we have the x-intercept, A0 down here, it doesn't matter what A is, but the y is always going to be 0. I know it doesn't seem right. It seems counterintuitive here, right? But if you think about it, it's 0 because we're not going up or down on the y-axis at all. We're simply going left or right on the x-axis. And that's why it is 0. And similarly, the y-intercept, notice how the b here is the one that actually moves, or the one that can actually change. And the 0 is the one that doesn't change. That's because for the y-intercept, we're not going left or right at all. Right? We're just simply going up or down. Now this is in the same vein of, I kind of wish it was a little bit more poetic, but it's not. Okay, so what do I mean by that? I mean that, we'll start with this first sentence. Okay, so this is to determine the x and y intercepts from an equation. Okay, so the first one, find the x-intercepts by substituting y equal to 0, and then solve for x. Okay, it would indeed be a lot more poetic if to find the x-intercept you can just set x equal to 0. Okay, but as we see over here, we have to set the y value equal to 0. Okay, because we're not going up or down on the y-axis, therefore we must set the y value equal to 0. Okay, and similarly, to find the y-intercept, we have to substitute x equals 0. Okay, so not much. We'll obviously do an example here, but it does seem kind of, you know, kind of wish it was convenient, find x-intercepts at x equal to 0, but that's not the case. Okay, so in other words, so you just kind of have to deal with, okay, to find the x-intercept, I set y equal to 0. Right? It does make logical sense, but it's just not as flowy. Right, and we will do that here. Actually, I can probably just go ahead and put this on this page. Yeah, so let's move things around, and we'll just go ahead and put this on this particular page. Okay. Alrighty, so it reads find the x and y intercepts. Okay, so my equation is 2x plus 4y is equal to 8. Okay, so we're going to find the x-intercept, and in order to find the x-intercept, I have to set y equal to 0. Okay, so let's go ahead and denote that we're going to look for the x-intercept. X-intercept. So it's going to be 2x plus 4 times 0 is equal to 8. And then we have 2x is equal to 8, or x is equal to 4. Okay, so that is how we find the x-intercept, right? And then, of course, if we were to plot that point, the x-intercept point would be 4, 0. Okay, so let's examine why that is real quick. Okay, so let's actually take a step back and see what we just did. Okay, so again, what I did was, in order to find the x-intercept, I had to set y equal to 0. Okay, and once I did that, well, 4 times 0 is just simply 0, so it becomes 2x is equal to 8, because 4 times 0 is 0. Okay, and then all I did was divide both sides by 2 to get x equal to 4. Right, and then how did I get my point 4, 0? Well, I said x is equal to 4, right, and that's what this point right here is, right? Well, I also said that y is equal to 0, and that's what that point is right there. Okay, so that's how I got those 2 points. I got the x being 4 because, you know, I got that from the algebra of setting y equal to 0. So that's how we get our points there. Right? And we'll do the y-intercept. Running a little short on room here, so it might be a little cramped. Okay, so we've got 2 times 0, because I've set x equal to 0 now, plus 4y is equal to 8. Okay, this means that I've got to. I don't think these toolbars show up on the YouTube video, but I've got toolbars down here. So I'm just going to kind of, do the arithmetic really quickly and just say that y is equal to 2, okay? Because this becomes 0, and then I end up with 4y is equal to 8, and then I divide both sides by 4, so I get y is equal to 2. So this means that my point, my y-intercept, is going to be, it's going to be a 0 for the x, and it's going to be a 2 for the y, just like that. So that is how I find my x and y intercepts. Oh, did it say to graph it? Yeah, it did say to graph it. Okay, so we're going to give you the good graph instead of me graphing it. Okay. So all you do here, and let's move that up here actually. Okay, all we would do here is we said we had the point 4. Let's put a different color. We said we had point 4, 0. Well, that's this point right here, right? And then we have the point 0, 2. Well, that's this point right here. And then you just connect the dots, right? We do end up, in this particular case, I'm sure it explains why in the textbook they had this other point, but you really only need 2 points to create a line, right? And that's what we did. We found the 2 intercepts, and we created that line. Same procedure there. All right, next up we've got horizontal and vertical lines. Go. All right. So horizontal and vertical lines, the whole premise of horizontal and vertical lines stems from what we have just done. Kind of. Okay. So this reads, recall that a linear equation can be written in the form ax plus by is equal to c, where a and b are not both 0. If either a or b is 0, then the resulting line is horizontal or vertical, respectively. Right? So the definition behind here, we have a vertical line is a line whose equation can be written in the form x is equal to k, where k is a constant. A horizontal line is a line whose equation can be written in the form y is equal to k, where k is a constant. Okay, so in this particular example, we have simply, let's see if I can just go ahead and grab the graph of it. And we honestly don't even need a table here because it's we from the definition we can see that this is indeed just a vertical line. Okay, so let's look at the equation. All right, your homework will say graph the equation x is equal to 6. Okay, well, judging from our definition here, okay, a vertical line is one that's just x is equal to something. This is x is equal to something. Therefore, we have a vertical line over there at 6. Okay, and that's honestly as easy as it gets. And I'm pretty sure we're going to have a horizontal line. I'm going to go ahead and put the horizontal line here as well on this particular page, just so we can bunch them all together. So, all right, there we go. It's horizontal. Okay, we don't actually have the vertical, do we? Oh, I got that. Well, we do have a horizontal, but it's this particular equation. Okay, not terrible. Current page. So we're going to have example 9 here. Now this reads, graph the equation 4y is equal to -7. All right, well, we know that we need to solve this for our variable, right? So we're going to end up with a y is equal to a -7 divided by 4. Okay, so we're going to have a horizontal line because our definition here says it's in the form y is equal to k. Right, so we're going to have a horizontal line at -7/4 on the y-axis. So what that looks like, that's not good, is this current page. Okay, and that's it. We have that horizontal line right there at -7/4. Okay, well, that concludes. I'm pretty sure that concludes. Let me make sure. I think we'd go straight to the exercises. Yeah. Okay, so that concludes chapter 2, section 1.